No.
Okay, Chris, that is not a good plan, I have to say.
I would rather use a pair of.
All right. So you should have these notes out. Okay, but the notes we're actually doing today are gonna be solving. Oh, it says exponential equations.
Is this easier or harder?
I would say basically you're just taking the last two lessons and putting it together.
Yeah.
You know, if you know how to do the last two lessons, today shouldn't be too bad. right. Let's take a look at number one. Okay, so at the top of your notes, it says that last time we learned, okay, let's put computers up, please. Okay, that logarithms
I didn't see that. I'm just whacking it with it.
and exponentials, okay, are inverses to each other. And you should know that inverses cancel each other out. Okay, maybe just put cancel each other out. Kind of too much right. Okay, but what I mean by that is that if you have a log little 3 and a big 3, they cross out and you would just get A. Okay, look at the second one. I have a log little 5 and a big 5, then what's going to happen? Cross them out, just the 2x plus 7. Okay, last one. I have a big 7 and a log 7. Now notice, the order is reversed this time, but it doesn't matter. A big 7 and a log little 7 are going to cross out. You're just going to keep the 3c.
But how are we doing this?
So logs and exponentials are inverses. So as long as the little number and the big number are the same, they cancel out. So if it's a log little 5 and a big 5, they cross out.
Then you just literally put the extra.
Uh-huh. All right, so now let's get into solving with that. Here are your steps. You are going to raise both sides of the equation to an exponent that has the same base as what the log has. Okay, then remember that logs and exponentials of the same base are going to cancel. And then you're going to solve using the common base method. Okay, when x is in the exponent. So let me show you what I mean by that. We're taking the last two lessons, we're putting them together. Take a look at number one when you're ready. It says log 3 of 81. Now the way that you would say this is a log base 3. Okay, the little number is called the base. So log base 3 of 81 equals x. How do I get rid of a log little 3? I'm going to use a big 3. So we put a big 3 here and a big 3 here. So now it's 3 up to the log 3 and 3 up. Okay. And 3 up to the x. So then what's going to happen is your 3 and your log 3 are going to cancel out. You're going to have 81 equals 3 to the x. That's where your chart comes in. Now you're going to go over to your chart in your old notes. You're going to look for 81 in the 3's chart. Okay, so 81 is 3 to the 4. That's right. So we're going to switch out our 81 for a 3 to the 4 equals 3 to the x. Okay, remember that you need to use the chart to convert that. And then from there, what happens when I have a big 3 on both sides? Cancel them out and x equals 4.
But like at the first, the start of the. Why we put the 3 on both sides? This.
Because the 3 will cross out the log.
If there was a 4,
You would put a 4. That's exactly right. Okay, so great question. So now look at number 2. What's the little number on number 2? What's the base of the log? Then I need to put an exponential base of 2 on both sides. Because remember, exponents and logs cross each other out. So now my big 2 on my log little 2 is gonna, whoosh. You're just gonna keep the 8. And 8 equals, this is now 2 up to the x minus 6. Okay, then you're gonna come over here to your chart. You're looking 8 up in the 2's chart. So look on your chart, what is 8 as a 2 power? Okay, 8 right here is gonna be 2 to the 3. So it'd be 2 to the 3 equals 2 to the x minus 6. And then from there, once I have those matching big 2's for exponentials, we can cross them out. And just set the exponents equal to each other. So I have 3 equals x minus 6. And then to get rid of the minus 6, what will we do? Plus 6, what's our value of x gonna be? 9. Okay. Let's take a look at the next one. Now, all of these rules that we did in this sheet are gonna come back. So try to really like focus in on this first section. It'll make the later examples easier. Okay, for number 3, what is my log base? What's the little number?
2.
2. Then I'm gonna do big 2, big 2. This crosses out. I have 1 equals 2 to the x. Okay, in your notes, I want you to turn to example 7. Example 7, this is from last time's notes. What power can I put on any base to turn it into a 1? 0 is correct. So if I want my 1 to be a base 2, I'm gonna do 2 to the. Okay, remember that any base that you put a 0 on, it's gonna yield you a result of 1. So going backwards, I can pick any base that I want as long as I put a 0 up top. Then from there, my 2's are gonna cross out. What's my x gonna be? 0. Also keep in mind on last time's homework, we did have some answers where 0 is the answer. That counts as a number 2. All right, take a look at number 4. What's my little number? Log little 7, then I'm gonna big 7 both sides. Big 7 and little 7 are gonna cross out. I have 1 over 49 equals 7 to the x minus 3. From here, look in your 7's chart, and you're looking for 49 as a power of 7. 7 to the 2, very good. So look right here. Okay, I'm looking for 49 in the 7's chart. I see it 7 squared. Now look back at your notes on the same page you were looking at before. What do I do to my exponent if it's in a fraction and I want to move it up? Okay, very good. If you want to move your exponent off the bottom, okay, if it's a fraction, you're going to use a negative on it. So instead of me putting 7 squared, I'm going to put 7 negative squared. And then I'm going to put right here, use negative exponent for fractions. Okay, use a negative exponent when it's in a fraction. Okay, then from there, we work it out the same. What am I gonna do with my big 7's? Cross them out. Then I have negative 2 equals x minus 3. How do I get rid of the minus 3? Plus 3 on both sides. Negative 2 plus 3 is gonna give me x equals what?
1.
1 is correct. Okay, let's do one more with a fraction. Let's do the next one. What's my log little number? 5. How do I get rid of a log little 5? Big 5's on both sides. Very good. These guys cross out. 125 sticks around. Equal to 5 to the x. Notice that your x is an exponent on the big 5. Okay, look in your 5's chart for 125. Okay, very good. So Oliver, do you know what chart we're looking at? So 5's are here, and I'm looking for 125. See how it's 5 to the 3? But then since it's a fraction, what am I gonna change? the exponent needs to take the negative. So it'll be 5 to the negative 3 and 5 to the x. Now that those 5s match each other, what can we do? Cross them out, and I have x equals negative 3. All right. Take a look at number 6. What's my little number? 5 log little, or sorry, I said it, log little 5. So I have root 5 equals 5 to the x. Now, last class, we talked about this. If I have a square root, think back in your brain, what power is a square root the same as? 1/2. So remember, it's 1/2 if it's a square root. So I'm gonna rewrite my square root as a 1/2 power, just like we did for logs, so that now I can cross those 5s out, and what does my x have to equal? 1/2, very good. Okay, we're gonna practice that a few more times, but if you wanna put a little note here, a square root equals a 1/2 power. Okay, a square root equals 1/2 as a power, and we learned that on our log day. All right, go down to the next row. What is my base on number 7? Log little what? Little root 2. So if it's a root 2 for the base, I have to put a big root 2 on both sides. Okay, so these guys are gonna cross out. I'm gonna keep my 64 equals. And then I have the square root of 2 up to the x. Okay, from here, remember that a square root is the same as what power?
1/2.
A 1/2. So then I'm gonna turn this into a 2 to the 1/2. Remember, the old exponent is gonna stick around, you just put it in parentheses. Now, for my 64, I gotta convert. So look in your 2's chart. We're looking for the number 64, 2 to the what? 2, 6, very good. Okay, and then once I convert my 64 to a 2 to the 6, my matching 2's can cross out. So my 2 here, my 2 here are gone. I have 6 equals 1/2 x. Half means divide by 2. How do I undo divide by 2? Multiply by 2. Which means that x equals how many? 12. Very good. Okay, let's do number 8. What is my base? What number? Log little square root 10. Then I'm gonna cross out a log little root 10 with a big root 10 on both sides. These guys are gonna cross out. I have 10,000 equals root 10 to the x.
How did we get 10,000?
That was already in the question.
Yep.
Okay, then from here, a square root is the same as what power? 1/2. So I'm gonna turn my square root 10 into 10 to the half, my x just chills. Okay, and then 10,000, you're gonna have to use your chart to convert that. It is 10 to the 4, very good. And actually, I'm realizing it got kind of hole punched here, but there should be another 0 right there. You wanna add that to your chart.
That was in the whole thing.
Yeah, and then this one up here is 1,000 for the one that got hole punched. If you wanna write that in.
Why do you all punch it?
So people can put it in their notes. Okay, so it's 10 to the 4 equals 10 to the 1/2 x, and I can cross those 10's out. And I have 4 equals 1/2 of x. How do we undo a 1/2 or a divide by 2? Multiply by 2, very good. So I have x equals 2 times 4 is 8. All right, number 9's kind of same old stuff, so let's turn the page. Okay. If Okay, if your X is little, that's how you do it. So can you look back at all these examples? Do you see how your X ended up top each time? You see that? Okay, so now let's look at the next question that's not gonna happen. Take a look at number 10. What's my log little number? 8. How do I get rid of a log little 8? Big 8 on both sides, so 8 and 8. These guys cross out. I have 5x plus 1 equals 8 to the 3. Okay, now at this point, I want you to notice where your X is. Is that a little x or a regular X? Regular, then I want this to go back to a regular number too. So look in your chart for 8s. What is 8 to the 3 the same as a regular number? So then I have 5x plus 1 equals 5, 12. So basically, if x is little, you're gonna convert the other side to have a little number too. If x is regular, you're gonna convert back to regular numbers plus u. So then minus your 1 across, what's 512 minus 1? 511, then divide by 5 on both sides, and x would be 511 over 5. Okay, for your homework, if you want to divide that and turn it into a decimal, it'll count it right as long as it divides. So if it was like something 0.5, that's fine. Okay, take a look at number 11. What's my log little? 3, how do I get rid of it? Well, it'll be big 3, and then they'll both cross out. That's exactly right, Nate. So my 3 and my log little 3 cross out. I have a 4x minus 1. 3 and log 3 cross out. I have a 2x plus 7. Okay, then from here, notice your x is regular, then you just solve it as is. So if I have x's on both sides, which one do we want to move? Okay, the 2x is fine. So I'm gonna draw my, I don't know if y'all did the railroad tracks thing. Okay, but I'm gonna minus my 2x across. 4x take away 2x is gonna be 2x minus 1 equals 7. What would my next step be? Okay, very good. Plus the 1 across. 7 plus 1 is gonna give me 2x equals
8.
and then divide the 2 across.
X equals 4.
Very good. Okay. Taking a look at that, do you have any questions? Okay. Now we're gonna get into what if you have multiple logs? Okay, so these are the rules that we just learned last class. Let me remind you what they are. If you have,
What does this say if no base is listed?
oh, thank you for asking. If no base is listed, okay, you're gonna use a base of 10. And that will happen on an example, but if there's no base listed, write it right here, it's gonna be base 10.
So it just says log, then it's 10.
Correct, and like, if you look on your calculator, you have a log button, it's automatically log 10. Okay? Alright, so if you have a log A plus log B.
Do we need a calculator?
I mean, if you're doing fine with the math so far, not really, but you're welcome to grab one if you want. Okay, from last class, how can I combine logs that are added? Do I multiply or divide to put them back together? Multiply is correct. So your A times B, oops, will go in the log when you put them together. I didn't mean to write my log little. It should just be log A together. Now, if my log A and my log B are minus, how do I put them together into the same log? Instead of multiplying, I would divide. Okay. And then the last rule is that if you have a number in the front, remember you can pop it up to the top. So it'd be log A up to the end. Okay, so take a look at number 11 for me. First question, I see multiple logs. So you can't do the log little trick and just do a big 8 on both sides if there's multiple. How can I take those 2 logs and put them into 1 if they're currently plus in the middle? I'm gonna multiply, very good. So I'm gonna put right here, I'm gonna multiply 6x times 2, what is that gonna give me? 6x times 2, what would that be? Log little 8 of 12x. That's exactly right. So in order to get my 2 separate log 8s into the same log 8, I multiply 6x times 2 is now a 12x. Now that I just have 1 log on this side, how do I get rid of a log little 8? Use a big 8 on both sides. Then remember that your log little 8 and your big 8 are going to cross out. You have 12x equals 8 squared. Now remember, x determines whether you want little numbers or big numbers. Look at your x. Is it a regular x or a little x? Regular. Then I want 8 squared to go back to being regular too. So look up in your chart. What is 8 squared back to regular numbers?
64.
Then 12x equals 64.
8 to the power of 4, what is that? 'Cause that's missing.
It's just, it won't come up. It's too big.
Yeah.
You can always look any of these numbers up in the calculator too, though, if you lose your list. Okay, then divide the 12 across. Okay, and then 64 divided by 12. That won't go evenly, so I'm just gonna leave it. Although actually, I think for your homework, you'd have to reduce it. So do the pretty fraction and put 64 over 12. What does it reduce to? Huh?
16 over 3.
16 over. Okay, but remember, the pretty fraction will do it for you. Just make sure you simplify. All right, take a look at number 12. Are the logs on the same side added or subtracted? And if they're subtracted, how can I squeeze them back together into the same log with multiplication or division? Division, very good. So I'm gonna write, I need to do 10x divide by 2. What is that gonna give me? Log little 5 of 5x equals. Okay, but notice that the reason I'm dividing there, okay, is because they were subtracted at the beginning. So then from there, now that I just have 1 log on the left-hand side, I can use my little trick that if it's a log little 5, I'm gonna do what? Big 5 and big 5. These guys are gonna cross out. 5 to the 3 needs to be converted back to a regular number. So let's look that up in our chart. What is 5 cubed the same as?
125.
125 is correct. And then to get rid of that 5, we'll just divide. What is 125 divided by 5? 25. All right, take a look at number 13. Yeah, I think we're almost to a good stopping point. Sorry that this is, I see it's a lot, but you're doing great. Okay, number 13. I have a log 4 plus 2 log x equals 2. Question, can I combine the logs with a 2 here? No. Where can this 2 move in the log properties? You remember it can go up. Thank you. So the first thing that I'm gonna do is I'm gonna take that 2 from the front and I'm gonna make it an x squared instead. So here's what I have now. You may not need to write this, but I'm going to. It's log 4 plus log x squared equals 2. Now notice, I still have more than 1 log on the same side. Okay, that's not allowed. I gotta put them together for me to solve. So if it's log 4 plus log x squared, How can I combine them back into the same log, multiplication or division? Very good. What is 4 times x squared? So I have log 4x squared equals 2. Now, as Oliver pointed out, okay, if I don't have a base, we need to know what base to put. What are we gonna put? 10 is correct. And now that I know that it's a log little 10, how can I cross it out? A big 10 on both sides, right? So I'm gonna do big 10 and big 10. So I have 4x squared equals. And then you have two choices. You can put this into the calculator or you can look it up in your chart. But what is 10 squared? What regular number? 100. Then from there, what do? Don't square root just yet. Divide that 4 out of the way, then we'll square root. So 100 divided by 4 gives me 25. And then take the square root on both sides. X is gonna equal 5. Now, usually, what would I have you put here when you take the square root? Plus or minus 5, but for logs, you can never have a negative x. So it'll just be 5. Okay. All right, let me see. I don't want to do all of these. Let me pick like.
No, let's do no more.
For which one? Oh, that's okay. Okay, that's a great, thank you for pointing that out. So, remember that your x can only not be negative if it's in the log. So see how here your x is on the other side, that's fine. Okay. All right, so let's just do 2 more. Which 2 do I pick? Let's start with the next page. Let's do this one. Okay, follow the steps that we're doing. The first thing is any front numbers, gotta jump them up. What number am I talking about? That's gonna have to move up. The 2. So now this is a 4 squared. So I have log little 3 of 5 plus log little 3 of x plus log little 3 of 4 squared is a number. What is 4 squared the same as? 16. Very good. Okay, from here, do you notice that you have multiple logs? You got to put all those logs into the same one. If they're all added, what am I going to do with those pieces to put them back together? Will I multiply or divide? Multiply. So in your calculator, can you multiply 5 and 16? What is 5 times 16? 80x equals 3. Okay, now notice I'm doing 5 times x is 5x, then times by 16, that's where we got the 80x. From here, how do I get rid of a log little 3? Big 3 on both sides. These guys are gonna cross out. 80x equals. And then because my x is regular, I want to turn this back into a regular number. So either put it in the calculator or look it up in your chart. What is it? 27 is correct. Okay, then from there, how do I get rid of the 80 in the front? Divide by 80. Okay, and then remember, if it's a fraction and it won't divide evenly, you could just leave it as a fraction. All right, last one we'll do together. Let's do the one right below that. All right, first question, are there multiple logs that we have to combine them? No. And it's a log little 2. So I'm gonna do a big 2 on both sides. These guys cross out. So I have 2x² minus 2x equals 2 to the 4. Oh wait, I wrote the wrong number, 2 to the 2. From here, are my x's big or little? Kenny, will you move your backpack so Adrian can sit? Okay, my x's are regular, they're big x's, and I need this to go back to a regular number. What is 2 squared the same as? 4. So I have 2x² minus 2x equals 4. Okay, question, we spent what feels like a million years solving these. Okay, you're gonna need to AC chart this. How can you AC chart it though with the 4? You need to bring it across to the other side and do it minus 4. So it'll be 2x² minus 2x minus 4 equals 0. Okay, remember, you can only AC chart with equals 0. And the reason for that is that your A, your B, and your C, they have to all be together on the same side. Now, I can AC chart right now, but is there anything I could divide out first to make it a little bit easier?
GCF2.
Yeah, GCF them all by 2. So this is now a 1x², 2 divided by 2 is a 1x in the middle, 4 divided by 2 is a 2. ABC. A times C is 1 times -2, what's that? -2. Only way to times to 2 is 1 times 2, there aren't any other partners. What is my basement number that I'm trying to get? -1. So where will I put the negative if I want the 1 to come out negative? On the 2, very good. So it'll be x minus 2 and x plus 1. Which means what are my x equals numbers? -2 will go to a +2 and +1 will go to a -1.
No, because
Yeah, remember, since everybody divided by 2, our A is a 1, we're done.
so we don't do anything.
You don't, and here's why. Remember, the 2 is here. But remember, only x's give you answers. So if there was a 2x on the outside, I would list 0 as a third answer. Okay? Then, this isn't really super important. Never mind, I don't want to keep you two. Okay, you good with that? All right, go ahead and get out your Chromebooks. That was kind of a lot.
There's a lot.
Would you like to do the thing? Okay. Yeah, these three little. Yeah, there's one right behind that box. I did record it. But. Were you taking a TSI? How'd it go?
It's 1,000. We balance in the report. 1,000.
That's not hard.
1,000.
Do y'all need paper?
No, thank you. I don't want to do it.
Kenny, you want? Okay, all of it. You know that letting our work build up, doesn't.
I know, it's already building up on Delta now.
Do you wanna come and hang out in my 4th period forever? Need paper?
The 4th period,
So you always, oh, it's 6.
yeah,
Want paper? Raul, how we doing, buddy? Paper? Oh, I do need to. Y'all need paper?
So it's basically like after we have a little bit more.
I missed like the entire last part of that.
I know. I noticed that.
Okay, so now taking a look at the back side. If you were to look up 40 in the twos chart, okay, you would notice that it's not ever gonna show up. So for example. Okay, the closest we can get in the twos chart is gonna be 32, but notice it never actually gives us 40. So what we can do now to get rid of a big two is we're gonna log little two on both sides. So then my little two and my big two are gonna cross out. I'll have x equals, and then we're just typing this into the calculator. So the way that you're gonna do that is you're gonna push alpha window and then go down to log base. Then I'm putting a 2 in this box, a 40 in this box. So I get 5.32. Okay, 5.321. Now for your homework, it's gonna tell you to round to the hundredths place. So that means that you would keep that as 5.32. However, after the 32, if this number was 5 or bigger, you would bump it up to be a 5.33. Okay, let's skip 17, go on to, let's do 18. So I have 4 to the x minus 5 equals 15. We're gonna add this 5 across first. So I have 4 to the x equals 15 plus 5 is gonna give me 20. Then from there, I could look at the forest chart. Remember, I'm trying to find 20, and I see that I never have a 4 of 20. I have a 16, which is kind of close, but it's not the 20 that I want. So what I'm gonna have to do on both sides is log little 4. Okay, log little 4, log little 4. Okay, then remember, a log little 4 on a big 4 crosses out. You have x equals, and then we're putting that into the calculator. So in my calculator, I'm gonna type in alpha window, go down to log base. And then I'm gonna put 4 in the little box, 20 in the big box. So it came out to 2.16 followed by a 0. If 216 is followed by a 0, then remember, that means I keep it the same. Versus if this number was a 5 or bigger, I would bump it up to 2.17. Okay. All right, let's do 2 more questions left. Take a look at number 20 at the bottom. So I have 6, 2 to the 3x minus 8 equals 10. Okay, you cannot just multiply these together. Okay, we're gonna need to go in order to get x by itself. So I'm gonna add the 8 across first. So 10 plus 8 is gonna give me 18. Okay, the next step, we're trying to get rid of the 6 in the front. These are multiplied, so I'm gonna divide by 6. 18 divided by 6 is gonna give me 3. And then to get rid of that big 2, remember, you're gonna use a log little 2. So then my log big 2 and my little 2 are gonna cross out. And I'm typing that into the calculator. So it's gonna be alpha window, log base. 2 in the little box, 3 in the big box. And I got 1.58. Okay, from here, divide by 3 on both sides. And now this is important for your homework. You want to use this full decimal to divide by 3. So if you just go up and push enter on it, then you could divide it by 3, round at the very end. So if I divide this by 3 in the calculator, I get 0.528. But if it's a 0.52 followed by an 8, that's gonna round to 0.53. So you just want to be careful on that rounding. You're rounding to the hundredths place. Okay, last one we'll do, number 19. Okay, first thing I see is this 2 in the front has to go. It's a multiply by 2, so I'm gonna divide by 2. So now I have 7 to the x over 3 minus 4 equals 20 divided by 2 is 10. Then I want to get rid of a big 7, so I'm gonna have to log little 7 and log little 7. These guys are gonna cross out. And I have x over 3 minus 4 equals, and I'm putting this into the calculator.
Okay, remember, you're always typing whatever that base is in the calculator. Okay, remember, it's alpha window to pull up the log. And it's option number 5. So log base, we're doing a 7 in the first box, 10 in the second. And I got 1.18. Okay, then look at your X. I got a -4, so I need to add that across. X over 3 equals. And then remember, in the calculator, you're not going to shorten this number until the very end. So I'm going to take my 1.18, I'm going to add 4 to it. Okay, that's 5.18. And then for my last step, if X has a divide by 3, then I'm going to multiply by 3. Okay, but remember, I'm not typing this in, I'm using this long decimal right here, and I'm going to times that by 3. Okay, so you don't want to round till the very end. So then I got 15.54 followed by a 9. Well, then if it's 0.54 followed by a 9, we would round that to 15.5.
All right, good job. You should be able to finish your homework now.